Let's go through LeetCode 768 max chunks to make a sorted. For this question, it gives us an integer array ARR, and we can split array into some numbers of chunks, or we call partitions. Here, the thing is that we say these chunks is that all of the chunks should not have any overlaps, right? So if like this, will not it is say it is a chunk, and that is we put array into different partitions, right? And also these chunks, all the chunks are going to make the whole array. So there is no overlapping and also no missing. So what it says that after and for each chunk we can sort individually, and after concatenate the sorted chunk, the result should equal to the sorted array. So what does that mean is that, for example, if we have chunk like this, right? We thought this part is 1, 2, 3, 4. And if we thought the second chunk, that is the 4, right? So this one, the sorted result concatenate this kind of result that is the same as we sort the array as a whole chunk, right? So we know at least this chunk will be 1, right? If we put one chunk, every numbers into one chunk. So it will always have a solution. But the question is asked, what's the maximal chance we can have, right? So let's look at the second example, right? You see that the maximal chunk is 4, right? So we'll see he put 2, 1 into one chunk, 3 into one chunk, 4 into one chunk, 4 into one chunk. And when sort 2, 1, it is 1, 2, right? And sort 3 is 3, and sort 4 is 4, and the sort 4 is 4, right? When concatenate, it is the same as sort the whole array. And we can prove that this 4 chunk is the maximum one, right? Because we cannot have 5, right? So if we have 5 chunk, that is 2, 1, 3, 4, 4. Apparently, this is not sorted. So how can we think about this question, right? So we should have some kind of strategy for this. In order that we have maximal chunks, is that for example, we are trying to find as many chunks as we can, right? So there is some kind of features. For example, we separate this array into 3 chunks. 3 chunks. The maximal of the first chunk, right, should be smaller or equal to the minimal of the second chunk. And also the maximal of the second chunk should be smaller or equal to the minimum of the third chunk, right? So in order to get as many chunks as we can, what we're thinking about is that we separate this array into as many as partitions as we can, right? As long as the maximum of this is smaller than for example, the chunk I, right? As long as the chunk I, the maximum of chunk I will be smaller or equal to the minimum of chunk I plus 1, right? So how can we do this, right? So actually we thinking about is that we can do preparations. One to get 2 arrays. One is called left max, and for every index, it will it is having the value of the max value on this index I on its left, right? And also include this I. And also we are going to have an array called right min. So for this index I, it will have the minimal values from this index to the end, right? So what we do is that if we have an index I, the left max is smaller or equal to the right mean of I plus 1, right? Then we can separate, have a partition here. That means every partitions over here will be smaller to the right, right? So as long as we find there is a left max smaller than right mean plus 1, then we do a partition. So in this case, we partition as many as we can, right? And return the final result. So let's write code for this. And we know we should have two arrays to prepare two arrays. One is called left max, right? New int, right? And so we have left max equals integer dot mean value. So what do we do is that for int I equals to 0, right? I smaller than I plus. So we'll have left max equals max dot max array I in the left max. And we'll have left max I equals max. Left max, right? And we should also prepare the right mean array. So int right mean equals integer dot max value. So what you do is that for int I equals I minus 1, I greater equal to 0, I minus, right? So we'll have right mean equals max dot mean, right mean, and array I, right? And we should have right mean I equals right mean, right? So we know if we don't have any partitions, right, then we'll have a one chunk. All of the numbers all of the numbers in the array into one chunk, right? So now we are trying to see how many partitions we have, right? So what we do is that for int I equals 0, I smaller than n minus 1, because we're trying to see whether it's right, still have value. So we should have at least one value for the right mean I plus 1, right? So I plus plus. So if we have left max smaller equal to right mean I plus 1, right? So we'll have result increase by 1, right? In the end, we just return result. And convert this to Python code should be very similar, right? And we have n equals length array, okay? And we have left max right mean, right? Because and we can also have the left max and the right mean values, right? This should be float minus RNF and this will be float. So let's compose the left max and the right min array. So for I in range, right, we'll have left max equals max, left max, and array I, right? So we'll have left max I equals mx, right? And also for I in range n minus 1 to -1, and we are doing from bigger to smaller, right? So we have right min equals min, right min array I, right? And we have right min I equals right min. Okay. So after doing this kind of preparations, we have result as one, right? And we trying to find the partitions as long as we have in one of part, the left max I is small equal to right min I plus 1 will increase the result. So we'll say for I in range here, because we want to compare to the left right part, right? So we just to range n minus 1. So if left max I is small equal to right min I plus 1, then we have result plus equal to 1, right? In the end, the return result. The space complexity is O n, and the time complexity is also O n.